Hey guys, we are here today. This is Algebra 2. We are doing lesson number 117. This is going to be letter symbols for sets and set builder notation. Okay, so with this, we're going to just look at some systems, some ways that we're going to write out sets. All right, so we're going to have a symbol here. It's got this little square here. It's an N. All right, an N with that little square on the end. This is going to refer to 1, 2, 3, etc. Okay, these are going to be the natural or counting numbers. Natural or counting numbers. All right, my next symbol is just going to be a W. That's nice and easy. This is going to be 0, 1, 2, 3, and so forth. These are going to be our whole numbers. All right, if I've got, here we're going to make a Z. All right, and it's going to kind of get a double line to it, like this. All right, still fancy looking Z. All right, that Z right there is going to refer to our integers, and that's going to be -3, -2, -1, 0, 1, 2, 3, right, and so forth. Those are our integers. Okay, integers are that fancy Z. Okay, here next I'm going to have a Q, and it's going to have a little second line down in there. This is going to be, these are going to be rational numbers, fractions, numbers that I can write as fractions. Okay, and we're going to call those rational numbers. All right, like -40/10 or -240/60 or -4. Okay, all of those. So see, look at, here's -4. I can write -4 as 240/60 or as 40/10. So looking at that -4, remember I can actually write it as a fraction. All right, our next is going to be P. P is going to refer to our irrational numbers. I've got square root of 2, pi, the cubed root of 4. These are irrational. All right, I have this fancy R. This is going to be real numbers. Real numbers are going to consist of rational and irrational. Okay, and so these are going to be real numbers. Okay, and then we have a C with an extra little line there, and this is going to refer to our complex numbers, A plus BI. All right, these will be complex. All right, along with this right here, remember that 3 plus 0i equals 3. So theoretically, even my 3 can be written as a complex number. It can just be a complex number whose imaginary part is 0. Okay, so we've got all of these symbols that we're going to be using here. This is set builder notation. All right, so with this, I'm going to, it's a compact way to describe a set. Okay, so remember this. Remember, we would have written x plus 2 is greater than 4, and my domain equals all integers. Okay, so now we're going to write this way. We're going to have A is a set whose members X, whose member X is an element of the integers such that X plus 2 is greater than 4. Okay, so reading this, A, so we're going to write this out. A is a set whose member X is an element of the integers such that x plus 2 is greater than 4. All right, let's think here. Can I have some different colors? Oh, I can't. Great. Okay, so let's look. See this A that I've got right here? And the equal sign and this right here? Okay, this refers to this. A is a set. All right. Let's look at this. Whose member X is an element of the integers such that this line right here means such that. And then obviously here at the end, the x plus 2 is greater than 4 and the x plus 2 is greater than 4. Okay, so that's kind of, we've got this set builder notation. That's what all these symbols mean. Okay, so, you know, again, we've got this A is a set whose member X is an element of the integers such that x plus 2 is greater than 4. All right, that's how you would read that. Okay, so this right here means is an element of. All right, and this line right here is going to mean such that. All right. Okay, so as we look at this right here, we do have over here this x plus 2 is greater than 4. Move my 2 over, x is greater than 2. All right, we've got the idea that this is integers, right? 2, 3, 4, 5. So bing, bing, bing. All right, that is what that is going to look like. So you're just going to have to deal with what these different you know, what these up here mean. Just learning all these symbols. N is the natural or counting numbers that begin with 1. W is the whole numbers beginning with the 0. The Z is the integers. Q, fractions are rational. P, irrational, R, rational. And C, complex numbers. Okay, so that shouldn't be too bad. All right, that is the first half of lesson 117. Now we're going to go on to a little bit more graphing here, okay? So let's see, if we've got, you're being told here to graph. All right, we want to graph y is greater than x plus 2, y is less than negative x, and our domain is going to be real numbers. Okay, we've been doing that before. All right, so now we're going to wind up writing this. The way we would write this in our notation is that we're going to graph a set whose members x, y are the ordered pairs of x and y. All right, graph the set whose members are ordered pairs of x and y, where x and y are real numbers such that y is greater than x plus 2 and y is less than negative x. All right. Okay. Oh, and we want to wind up, actually, we're going to add a little squared up here. All right. If I've just got this like this, that's going to be a real number on a one-dimensional line. But if I want it to be on a plane, a coordinate plane, I'm going to do that, and that's going to indicate the fact that it's a real number on a plane, a two-dimensional, and xy is a point on the real number plane. Okay, so this right here is what we're going to call the number plane, the real number plane, where this right here is that number line, the one-dimensional. Okay, one-dimensional, two-dimensional. All right. Okay, so, and as a matter of fact, as long as I've got this right here, let's deal with this, graphing this. The y is greater than x plus 2, and y is less than negative x. Okay, think of this y is less than negative x as y is less than negative 1x plus 0. So my slope is, negative 1 over 1, and my y-intercept is 0. All right? And this is my slope. All right, and we're just going to go ahead and graph these two. So we have this, and over here, the top one, my y-intercept is 2. 1, 2. My slope is a positive 1, so I've got up 1 over 1, up 1 over 1. Here's going to be my line that I'm going to draw here. And it just says that it's going to be greater than, not greater than or equal to, just greater than. So it's going to be a dotted line. All right, this other one is also going to be a dotted line. All right, we're going to start at the origin, because, see, there's no y-intercept there. So the y-intercept is 0. So we're starting here, and we're going to go up 1 over 1. Because it's negative, we're going towards the left, up 1 over 1 here, up 1 over 1 here, and we're going to draw this line there. Okay, so this first line, this line here, it said that y is greater than or equal to x. So this means that this refers to the area that's going to be above that line. All right, with the second line, it's going to be the area that's below it, because it said y is less than or equal. So the area that is above the first line and below the second line is just going to be this area over here. All right, so that's how I would graph that. Okay, just graph your two lines, figure out above or below. All right, that is all for lesson 118. I hope that helps. Check your email for your homework.